So we are looking at notes 3.3 here, and we are going to compare functions. And so we're on page, make sure you turn to page 172, and also make sure that whatever I write down, you write down. Okay, so when we compare, we're obviously looking, depending on the question, we're looking for if a number is bigger or smaller, and we need to compare commonalities. Okay, so we need to compare two things that are common. So if we look at this first example, we have a table and we have this graph. And so in order to compare, to find out maybe who has a faster, who's faster at welding these tasks, we want to find the constant rate of change. And so we can see that one of them, the constant rate of change is 10.4, and the other is 11.2. So one is moving faster than the other. So when we're comparing functions, and especially linear functions here, we're just looking at our constant rate of change, our slope. So that's nothing new. Example. In example 2, it says compare a linear and a non-linear function. Okay, well, first of all, we know linear means straight line. Okay, and nonlinear means not a straight line. So if we're looking here at our linear and nonlinear example, all I really want to point out in this example is how we know that this table is linear is because they show you that the x is increasing by 1 every single time, the same number, constant rate of change. And the y is also increasing by the exact same number every single time, the number 4, so also has a constant rate of change. So if we ever look at a table and we want to know if it is linear or not, we can look at what each of the values are changing by. We know that our graph over here, this is nonlinear, and we know it's nonlinear because it does not create a straight line. We have a curve there. Okay, and it does not have a constant rate of change. Okay, so these are harder to compare. Both relationships are functions, but they're harder to compare when you're not comparing like a linear to a linear. And last but not least, comparing more properties. In example 3, we have function A and function B. One is just the equation, and one is the graph. Okay, and so if we were going to compare these, again, comparing, we want to compare the same things. So we would compare our constant rate of change here. We look at our slope. My slope for this one is 2. These are both linear. And my slope for this line is -0.5. It's actually going down. Okay. So it's actually going down. So your slope is bigger on function A. But if you want to compare what we call our initial value or our y-intercept, that is bigger on function B. Linear, nonlinear, and comparing things. So compare the properties of these two linear functions. So let's look at the try it together. We know that the 2 is our slope in the equation. We know that the -4 is our beginning value or our y-intercept. Let's practice finding our slope. I'm going to pick 2 points. So we have our x and our y and our x and a y. And so if we look at this, our y's are on the top. So we have 5.5, take away 1. I started with this 5.5. I'm taking away my 1. Those are in the numerator. And so now let's look at the denominator. We'll have 5 take away 2. So we have 4.5 and 3 divided by 3. And I can tell you this is going to be less than 2. It's going to be 1 point something. Okay, it's going to be 1 and 1.5 actually. It's going to be 1.5, 1.5. So if we want to compare these two, we could say that function 2 has a greater rate of change. Function 2 has that greater rate of change. The concept box that kind of summarizes everything. And so what I want us to look at here as we kind of summarize things, we have a table, we have a graph, and we have an equation. And so what we notice about our table is that it's showing what everything's counting by. So we know that's a constant rate of change, so we know that's going to be linear. So we know this table is linear. We also know it's a function because all of our x values are different. Let's go ahead and look at the equation. We know in our equation we have a constant rate of change. It's in slope-intercept form, which is the y equals mx plus b. So it is also linear. And it has a constant rate of change with an initial value. And then our graph. We know our graph is linear. How do we know our graph is linear? Because it's a straight line. And they found the slope and the y-intercept for us there. So we're going to identify and we're going to compare slopes and y-intercepts. And we're going to identify if our graphs, tables, and equations are linear or nonlinear, and if they're functions or not. So we'll do the practice in class.